Good morning, ladies and gentlemen of Algebra 2 Honors. We're going to continue working on these adding and subtracting of rational expressions. And so we had a process of what were some of the things we were looking for when doing these problems? Pardon me? Common factors, common denominators, anything else? Excluded values, okay. And so really that's it. And then, but with factoring, you're going to be able, you hope, to simplify things. But to me, what makes this part one of the more challenging parts of our course is a lot of times you don't know exactly where you're going to end up. And so to me, you just keep on working until you can't go any farther. But sometimes there might be something you miss. But that's just sort of symptomatic of this. And a year from now, those of you in pre-calculus will be working on trigonometric identities. It'll be a similar sort of a thing. So anyway, what I want to do on this one here is find somebody to help me find excluded values, common denominators, and just kind of work through the problem. Would that be okay? Yeah. Yeah, so somebody just help me with that. We had a quick poll in class yesterday, and several of you said you dreaded being called, which a little bit of anxiousness is not always a bad thing. But let's see who we are. Bryce didn't make it here. Braden is not here. And I think everybody else is here. Okay, yeah. All right, here we are. We have everybody, I think. Let's see how we go. It's going to give us, here, Jose, it looks like. All right, Jose. All right, Jose. What do you think?
So, I don't really know what's going on that much.
Okay.
Yeah. So, we find the x can't equal.
Okay, let's do that, That's a good place to start. I'm with you. So what can x not equal?
0.
I think 0 is okay. You know, if I plug 0, I don't get divided by 0. What can x not be?
2.
Let's take a look. Yeah, it can't be 2, because that wouldn't work, right? So x cannot equal 2. All right, what else?
-2.
X cannot equal -2. Any other exclusions to the domain?
And then, so the square root of -4.
Pardon me?
Like, it can x not equal the square root of -4?
Look, let's do that. Let's set this up here. We say x squared times 4 cannot equal 0. So we have x plus 2, x minus 2 cannot equal 0. So what are the excluded values? Same as these, right? So to me, it looks like these are the excluded values we have. Okay. What else? Is there a common denominator?
X plus 2.
X plus 2. I don't like this guy right here. I don't like it. I don't like 2 minus x. what do we do to fix this thing to more like a standard form? Yeah, so I'm going to do that. I'm going to rewrite that as somebody said that, was Rindy or somebody?
It was Haley.
It was Haley? Yeah, so we're going to do that. And then we have 1 over x plus 2, x minus 2. And then Haley made a suggestion. We have this x plus 2. If she says we have negative x minus 2, is that right? And then we have a negative sign down here, so we can do something with that. We can get rid of that negative sign and move it up here. So that's going to be a negative negative, that's going to be a positive. So we can just make this positive up here. And that's going to be, that's like distributing that negative sign. So now we have this.
Oh, what about the top?
What's that?
Did you change the top?
Yeah, we did. The top was right here.
You don't have to change.
So this negative sign came out here like Haley suggests, okay?
You don't have to change the numerator?
No, because the numerator is already in place.
Okay.
Okay, we don't have to change, but we are changing the numerator by making this positive. That's what we're doing. Because we have this negative sign here, and we're just transferring that negative up here, because negative negative is positive, or negative times, you understand what I'm saying, don't you? Yeah. So we did take care of the numerator. That's how we did it. So what is going to be our common denominator on this guy?
X plus 2, x minus 2?
X plus 2, x minus 2, okay? Okay, so let's do it. So here we have x minus 2, and here we have, in the denominator, x plus 2. So what do we need to multiply this guy by right here? Somebody said x minus 2 right here. Somebody who was right. Okay, so here we have x minus 2 here. So that's, and when you do that, you got to make sure that you're multiplying by everything here. Okay. So next, we already have that common denominator here, don't we? So we have plus 1 over x plus 2, x minus 2. And then finally, we have this over here. We have x plus 2 over x minus 2. And what do we have to do with this guy now? X plus 2. Yeah. Now one thing that helped us out on this thing right here, we had this minus sign, and by Haley's factoring out of that negative sign there, we were able to get rid of that negative sign and just have plus signs across, right? Okay, what next? Cancel out here? No, we can't do that because we designed this with these common denominators. So we did this specifically to not cancel out.
We could combine them all, can't we?
Well, we can, but we have to do some work here. So let's see if we can simplify this all. So what do we have when we multiply these together? X squared minus 2x minus 2x plus 4. So I'll say minus 4x plus 4. And then we have our plus 1. And then we multiply this guy together here. So we're going to have plus x squared plus 4x plus 4. And that's going to be all over this thing here. Okay? So what do we get for the, what do we get when we combine the like terms here? What are the combined like terms here?
2x squared plus 9.
So 2x squared plus 9, you say this cancels out. That'll be plus 9, won't it? Over x plus 2, x minus 2. Everybody see where you got 9 from? 4 plus 1 plus 4. And 4x minus 4x cancel each other out. Is this factorable any farther factorable in the numerator here? No, it's not. So is this the end of our road? So x cannot equal plus or minus 2. So that'll be it, right? And you know what I'm going to do, don't you? I will, but I'm going to check the book. This is the moment where it's like, oh ye of little faith.
Mr. G, can we get more of tomorrow's papers? Can I get one of the reading?
Yeah, and I'm not sure how far we'll go into tomorrow either, but I'll do that. I'll get some for you. Yeah, I'm not sure. Okay, 10, 17. Get my stickers here for Jose.
Mr. G, are you okay?
Yeah, I'm just running a little slow today, that's it. I'm better than I was yesterday. Okay, Jose, why don't you take a look? Okay, Jose, here it is. 17, right.
Exactly what we done.
Great work, that's great work right there. Thank you, Jose. Yeah, it's the same solution. All right. Any questions on this? It's not that hard, is it? It's not that hard, is it?
Yeah, a little bit.
It's just a bunch of steps.
Bunch of steps, yeah. Yeah, that's what it is. That's what it is, it is steps, you're right.
What's marking?
Huh?
Let me go here.
How's it feel?
I understand in 8th period yesterday,
How's it feel?
there was a lot of debate
How it
over these problems, 8th period. So we're going to go over that in 8th period today.
He's here.
Okay, next, 18. So, just look at this one here. I'll call somebody in a minute.
18?
I'll call somebody. So do you all like the Super Bowl halftime show? You liked it? See, people of my generation that I talked to didn't like the show, but I think it's just like a generational thing. Because if you look at the guy definitely had production value and talent and everything. So if they didn't like it, it was just a matter of difference of taste.
Yeah, there's some theories like that. I saw a theory that like the guy with the mascot.
I liked the performance myself, but
The Us.
I watched
I've watched that movie like
The first
3
10
times.
minutes is the stupid bunnies and there's some
Yes.
music and all
Yes.
that.
Oh
What in the
yes.
world?
Yes. I know.
Did you also-
I watched it like 3 times.
what about the
It
Super?
just scares me.
What about the commercials? Did you like the commercials?
Commercials are okay. My favorite one was with the ponies.
Ponies, yeah. Ponies,
The ponies were funny.
The Clarksville.
yeah, Clydesdale's got turned loose. Okay, Randy, I found you some of these here.
No,
Thank you.
Couple.
I just pay attention if the horse. What? Yes, you don't know what to do.
Okay,
We can turn that negative into a positive, right?
yeah, you mean that last one there?
Yeah.
Yeah. So let's do that. I will do that according to Jose's suggestion. So I'm gonna go ahead and say, so we have x plus 3 here, minus 1, or x minus 3. And Jose is doing something like this. So you have this x plus 2, and then you have this minus x, is it x minus 3? Yeah,
It'll become.
that's going to be right, isn't it? Because minus, that becomes plus, or that becomes, yeah, that minus negative, that's plus, that's negative. Okay, and then just one other little cosmetic thingy here. We know that's negative, so what I'm going to do is this. I'm just going to go use that negative sign up here. Does that look okay? So I just took that negative sign here and just moved it up here. Okay, let's go ahead and choose somebody here. It'll be Aaron, okay, Aaron. All right, Aaron, what do you think? What do you think, Aaron?
I didn't get very far.
Let's do it, let's see what you did. How far did you get?
Just x plus 3, x minus 3 cannot equal 0.
X plus 3 cannot equal 0.
And then
X minus 3 cannot equal 0. So x cannot be equal to
3 and then cannot be negative 3.
plus or minus 3, okay? So x is not equal to, that's a not equal to plus or minus 3, okay? Good.
That's as far as I got.
Okay. What's going to be our common denominator here? What's our common denominator?
X plus 3, x minus 3.
X plus 3, x minus 3, everybody see that? Okay. All right. Looks good to me, looks good. So let's just continue here with this. So that's going to be equal to x minus 3. And what do we have to multiply this by here? What do we have to multiply this by to get our common denominator?
Like you said, X was 3.
To get our common denominator, what do we have to do with this guy here?
Oh, you, like the,
Thank you, Aaron. Aaron's voice is getting a little high.
A little sexy.
getting puberty.
Yeah, voice is scratching. All right, Good job. Okay, what next? Minus, we have 1 over x minus 3. And what do we multiply this by? X plus 3, right?
Yeah.
So here we have x plus 3 up here. And now finally we have this minus, and so we have this x plus 2 over x minus 3. And what do we multiply this guy by? X plus 3, right? So now we have our common denominator. So we have this x plus 3, x minus 3. And then what do we have on top here? Multiply this guy together, right? What do we get? We multiply this guy together right here. X squared. I'm getting x squared minus 3x minus 3x, so minus 6x plus 9. And then we're subtracting this thing here. So minus x minus 3. And then we're subtracting this guy here. So minus x squared. And then we have 2x plus 3x, so that's going to be minus 5x. And then we're going to have minus 6. And if we simplify all this out, we should be good, right?
Yeah.
So what is that going to give us? We know we're going to get x squared minus x squared, right? Boom, boom, boom. So we get minus, minus 7 minus another 5, minus 12, minus 12x. And what about numbers? We got
It cancels out.
9 minus 3 minus 6. That looks like it's just it, isn't it? So we get x plus 3, x minus 3. Okay,
Mr. G,
again, yes.
can I have one of the papers for tomorrow?
Yeah, I'll get you one too.
Let's go see. Yeah, there's,
Have number 18 come up for us, Aaron. Check out number 18, how that looks. Pretty good.
Looks amazing.
Is that okay?
yeah.
All right, very good.
I did it.
All right, good job, Aaron. Okay, good. Well, probably just because of where we are with 2 minutes left in class, we're probably just going to have to disassemble here. I'm not sure what we'll do tomorrow. We might
Nothing.
How about we go party?
We might start on multiplying and dividing. Yeah, because we're getting into word problems. I'm not tremendously excited about these word problems, but we'll just call it good, okay? Yeah, and Kendall,